In this lesson, we're going to cover some more material out of Unit 3.4 using algebra. We're going to take a look at the content in box H here, simple factoring. And by the end of this lesson, we should be able to factor simple polynomial expressions. The first question we need to ask ourselves or answer here is, what is factoring? Well, put it simply, factoring is the opposite of expanding. We looked at, in a previous lesson at how you expand things using the distributive property. So if we had an expression like 3x times 2x plus 5, we've got a binomial here in the brackets, and we've got just a single term out in front. What we knew to do was to take this 3x and multiply it by everything that was inside these brackets. So we took the 3x, we multiplied it by the 2x, then we took the 3x, and we multiplied it by the 5. And when we did that, we got an expression like 6x squared plus 15x. So we took this thing where we saw a term out front and then an expression in brackets, and we wrote it as sort of two terms added together. Factoring, we want to do the exact opposite. We start with something that has these two terms added together, and we want to write it as something in brackets with a term out front. So in this case, this will end up being written as 4x times x plus 2. And you can see here that if I were to take this expression that I just wrote, 4x times x plus 2, and I were to apply the distributive property, like this and like this, I would get 4x squared plus 8x. Okay? So we're just doing the opposite of what we were doing before with the distributive property. When we were expanding, we were trying to get rid of the brackets. Okay? When we're factoring, we're trying to add these brackets. Okay, so our answer should always look like something in brackets with some term out in front. But before we look at how we do that, we've got to talk a little bit about what it means to have a factor. And the term we're going to use a lot here is the term greatest common factor. So the greatest common factor is the largest number or term that will divide evenly into each of these terms that we are interested in. So as an example here, I've got two terms, 81 and 36. Okay? I am looking for a number that will divide evenly into these two numbers. And in fact, I'm looking for the biggest number that divides evenly into each of these two things. Andrew, why is it 9? You're absolutely right. Why is that, Andrew? Yeah. Or I can think of it as 81 divided by 9 equals 9, so it divides evenly. And 36 divided by 9 gives me 4, so it divides evenly, because this 9 and this 4 don't have fractions or decimals or anything like that. Now, if I've got something like x to the power of 5 and x to the power of 3, I'm looking for something that divides evenly into both of those. And in this case, it's going to be something that has x in it. Okay? So what can I divide x to the power of 5 by, or x to the power of 3 by? Well, in this case, the greatest common factor is going to be x cubed. Okay? Because if I do x to the power of 5 divided by x to the power of 3, I apply my exponent rules, 5 minus 3, I get x squared. And if I do x to the power of 3 divided by x to the power of 3, I just get 1, because I've got the same thing in the numerator and the denominator. So our first step in factoring is always to find this greatest common factor, this largest term that divides evenly into the terms that we are interested in. So let's just look at a few more examples here. Okay? And there's a set of steps that you want to follow if you're finding the greatest common factor for a set of terms. So here I've got two terms, 2x squared and 8x to the power of 4. There are 3 steps we are going to follow to find the greatest common factor of these two terms. And I've just written them down here at the side. So you probably want to copy these down just at the side of your page there. First thing we're going to do is we're going to find the greatest common factor of the coefficients. Then we're going to look at the variable terms, and we're going to find the greatest common factor of the variables by looking for variables that are common to all of the terms. And of the variables common to all terms, we're going to choose the lowest exponent of each common variable. So we've got 3 examples here to sort of see how these steps work. So our first example, 2x to the power of 6 and 8x to the power of 4. Our coefficients are 2 and 8. What is the greatest common factor of 2 and 8? It's going to be a number. It's going to be a number that divides evenly into both 2 and 8. What do we think? What number divides evenly into both 2 and 8? 2. So our greatest common factor of these 2 things is going to be 2. So we've got the greatest common factor of the coefficients. Now, we look for variables that are common between these 2 terms. Well, we see an x here, and we see an x here. So x is common. So our greatest common factor has to have an x in it as well. Then we get to step 3, choose the lowest exponent of each common variable. Well, here I see an exponent of 6. Here I see an exponent of 4. So I choose the lowest of those 2, 4. So my greatest common factor is going to be 2x to the power of 4. Let's try our next example here. I'll just say greatest common factor equals. Our 2 terms are 24a squared b cubed and negative 16a to the 5b. Start with the coefficients. 24 and 16. I'm just going to ignore that negative sign there, okay, for right now. So 24 and 16, what number divides evenly into both 24 and 16? 4 does. Is there a bigger number? 8. So our greatest common factor has got to have an 8 in it. That's from the coefficients. Are there any variables that are common to both of those terms? What do you think? Emily. A and B are both common. So my greatest common factor has to have both A and B in it. Got an A and a B, an A and a B. For each of these, I'm going to choose the lowest exponent of each of these common variables. So I look at my A's. I've got an A squared and I've got an A5. What exponent is going to be in my common factor, Sandella? It's going to be squared because that's the lowest one. What about for the B's? It'll just be B. Why will it just say B? Yeah. So we got B to the 3 over here. Here we don't see anything. We assume this is a 1. So 1 is lower than 3. So we're just going to have B there. All right. Next one here. 3x squared and xy to the 5th. Greatest common factor is going to be, well, first we look at the exponents. First we look at the coefficients. We only see one coefficient. We only see a 3 here. So there's no number to compare it to. So our greatest common factor isn't going to have a number in it. Okay? We could, if we wanted to, pretend that there was a 1 out front here. And then the greatest common factor between 3 and 1 would just be 1. But then we wouldn't write the 1 down here anyways, so we can just ignore that altogether. So there's no numbers to compare here. So let's just look at our variables. What variables are common between these 2? X. And what's the lowest power of x that you see there, Sandella? It's going to be 1, or just x like that. Now, why don't I put a y in here? Because y isn't common to both of them. So the only thing that's common to both of these terms is the x, and I'm choosing the lowest power there. So once we know how to do the greatest common factor, now we can start talking about how you factor. So flip the page over. There are 3 steps to factoring polynomials. Oh, sorry, 4 steps. All right. So I'll give you a chance to copy them down in just a minute, okay? So let's just go through this first example here, stepping through the steps, and then we'll write them down a little bit. First thing we're going to do is we're going to put brackets around our terms. Okay, so I'm just going to move this over a little bit. I'm going to take this thing and I'm just going to say this is my polynomial right here, 3x plus 6. That's what I want to factor. Next step, I'm going to look for the greatest common factor between those two terms in the brackets. So what is my greatest common factor going to be here? Well, let's see. I got two numbers, 3 and 6. What divides evenly into both 3 and 6? 3. So my greatest common factor is going to have a 3 in it. Is there a variable common to both of these? No, so no variable part. Okay. So we've got our greatest common factor. That's step 2. Step 3 here. We're going to start a new line. We're going to put that greatest common factor out front. And everything inside the brackets here, the 3x and the plus 6, we're going to divide by that greatest common factor. So in here I'm going to do 3x divided by 3 plus 6 divided by 3. And then I'm going to simplify what I have inside those brackets. I'm going to keep the 3 out front. 3x divided by 3, well, 3 divided by 3 is just 1, so that's just going to give me x. 6 divided by 3 is going to give me positive 2. And there, I've factored that polynomial. Okay. So take 2 seconds here and write down these steps on the side of your page here, and then we'll do the other examples. Okay, let's try our next example here. We've got 8x squared plus 2x plus 10. First thing we want to do is we want to say, okay, these are the terms. This is the polynomial here that we are going to factor. We want to first find our greatest common factor. So we look at our coefficients. What is the largest number that will divide evenly into each of those coefficients there? 2. Then we look at our variables. Is there a variable that is common to all 3 of these terms? Yes or no? No. So our greatest common factor is just 2. So we put our 2 out front, give ourselves the brackets again, and we're going to divide each of these 3 terms by that 2. 8x squared divided by 2, I'm going to need more room here, plus 2x divided by 2, plus 10 divided by 2. Keep that 2 out front, and then in the brackets we're going to do our division. 8 divided by 2 gives us a 4, so we have 4x squared. 2x, let's see, 2 divided by 2 is going to give us 1, so we're just going to have an x. And then 10 divided by 2 gives us 5 as our answer. So our factored expression is 2 times 4x squared plus x plus 5. All right, our next one here. Okay. 24x to the power 4 minus 12x cubed minus 4x squared. These are the terms that I want to factor. What is our greatest common factor going to be? We look at we look for something first that divides into all the coefficients. Cinderella's all over this one. Right. Then we look for our variables. Is there a variable common to all 3 of these terms? What do you think, Emerson? Yeah, so we know we're going to have an x here in all 3 of these. Because we have an x in all 3 of these, we're going to have an x in our greatest common factor. And then we look for the lowest power of x that we can see there. What is the lowest power of x? Still on you, Emerson? 2. So we're going to have 4x squared as our greatest common factor. Put our greatest common factor out front. In the brackets, we're going to divide each of these terms by 4x squared. 24, x to the power 4, divided by 4x squared, plus negative 12 cubed, divided by 4x squared, plus negative 4x squared divided by 4x squared. Okay. Notice I always keep those signs with the terms that they're in front of, so that becomes a negative 12x squared. I always have addition signs in between. I'm always going to have this 4x squared out front, and now I've got to do this division. 24 divided by 4 gives me 6, and then I apply my exponent rules here. X to the 4 divided by x to the 2, I subtract my exponents, x to the 2. Negative 12 divided by 4 gives me a negative 3. Keep my x, subtract my exponents. 3 minus 2 gives me 1. And what am I going to have for this last term here? I got negative 4x squared divided by 4x squared. Negative 4 divided by 4 is just going to give me negative 1. And when I do x squared divided by x squared, I subtract those exponents, and I end up with 0. So I'm just going to leave it as minus 1. Okay. So I've got 2 more here. I think that's enough for now. So at the bottom of your page, though, you have 2 questions that are pretty simple factoring questions. Give those 2 a try, and then move on to something else.